Hello, everybody. Welcome to lesson 3 on trigonometry. I hope at this point you've checked your work and your answers for lesson 1 and 2. We're going to get into a little bit more complicated problems now, and you may have a few more questions. So this one is going to be a little bit more challenging. The first thing you have on yours is a do now. This is a Regents question, so I just want to go through it for a second with you, and then I'm going to ask you to pause and do that problem. So the diagram shows two similar triangles. Because the triangles are similar, we know their angles are congruent. So the angle that's marked with that Greek letter theta is also in the triangle on the right, as I indicated. And then if they're telling you the tangent of theta is 3/7, I put the 3 and the 7 in for tangent, opposite, and adjacent sides. The ratio must be the same for every angle that measures the same as theta. So you can use the tangent of theta on the triangle on the right is 2.4/x. So then look at my red proportional relationship here. Tangents of theta are equal to each other, so 3/7 equals 2.4/x. So I finished it. You should get 5.6. Please pause yours and just pause the video and just work through that for a second, just to be sure you understand that. Okay? All right, welcome back. If you have any questions on that problem or any problem, you can email me. We can set up a time to chat live where we, like an extra help session, if needed. Okay, we're going to start working on word problems to apply the trig that we learned to word problems. And there's two important things you have to know. One is, where is the right triangle? You're going to be given all these situations with diagrams and where is the right triangle? Where is my angle, opposite side, all that stuff. So I made these problems up using some clip art. I want you to think about where is the right triangle in this situation. So the springboard used by the gymnastics team, this is Sydney, by the way. That's Sydney doing her gymnastics. The springboard used by a gymnastics team has 6-inch coils and forms an angle of 14.5 degrees with the base. How long is the springboard to the nearest inch? So here's our situation. Where is our right triangle? Your first question is, where is my right triangle? I'd like you to think about that for a second, and I'm going to pause long enough for you to think where you think the right triangle might be. And if you have your PDF open on your iPad, you can draw in the right triangle, because I'm about to draw it in on mine. I put the given information in the diagram because that helps me to think about where the right triangle is, where those numbers are. Okay, so I'm going to have the coil as one leg and the base of the springboard as a second leg, and the hypotenuse is the board itself. And that's what we're looking for here. I hope you thought that's where that triangle goes as well. What trig function would you use to solve this problem? Well, what information do you have? We're dealing with this angle, 14.5. Here is your right angle. And we have the opposite leg and the hypotenuse, which would call us to use which of our functions? Opposite and hypotenuse call us to use sine. So I'm trying to model for you what you have to do. Okay? You have to read the information, mark up your diagram, decide where that right triangle is, then decide what you have and what you need to decide what function to use. So this is a sine question. The sine of 14.5 equals 6/x. Now, no, my plan was to tell you, okay, you guys calculate that on your own time and come up with an answer. But I just want to use this moment with you on the video to show you what to do in this case, because I've had some questions on this on emails. Okay, when the variable's in the denominator, it's a one step harder algebraically to solve. I think you probably feel comfortable if you do this. Put your function and angle over 1 and cross multiply. So we get x times the sine of 14.5 is equal to 6. What do we do when we get to this case? This is where people have been asking me, what do I do to solve this? Divide by the sine of 14.5 on both sides. Okay? Just like if you had 6x equals, let me not use 6 because this problem has a 6. This has nothing to do with the problem. If you had 5x equals 45, what would you do to get x alone? You would divide by the thing that's being multiplied by the x. Divide by 5, divide by 5. Okay, come back to this, to the left side now. What's with the x? Sine of 14.5. They go together. Remember those parentheses inside the calculator, right? So the sine of 14.5 is being multiplied by x. To undo that multiplication, you're going to divide by it, okay? The rest is calculator work to find x. And then just let me give you some advice. Make sure you're paying attention to what are we rounding to. All these questions are going to involve a round. Okay, next. This is the part that's a little bit tricky, all right? And if you don't think it's tricky, that's great. An angle of elevation is formed by the horizontal line that your eyes are normally fixed upon. So right now, if you could just hold your head up and gaze straight ahead, that's your normal, comfortable line of sight, okay? Now, if you raise your eyes from that place up to look at I don't know where you are. Like I'm looking out a window, so I'm looking up and I see a very cloudy sky because it is Monday and it's a rainy, yucky day. Okay, but you might be looking up into your bedroom to see the ceiling, or you might be wherever you are, look up. Now you've elevated your eyes, haven't you? You have an angle of elevation from where your eyes naturally are, horizontal from their normal steady position, chin straight. That natural, I look up, that's called an angle of elevation. And you can see in this diagram, there's Goldilocks. She's walking to her grandma's house with her little basket, and her normal line of sight is the red line, but she sees a hot air balloon. What would we naturally do when we see a hot air balloon? We're going to elevate our eyes, look up to see it. Oh my gosh, look at that. I never saw one of those before. And then her line of sight is now elevated, okay? The angle of elevation is the angle formed by her normal, comfortable, horizontal eyesight and looking up. All right, now, I do want to explain to you that sometimes the height of Goldilocks, okay, her height is sometimes taken into account in a trig problem, and sometimes it is not taken into account. What? That sounds crazy. I know. It sounds crazy. If we were in the classroom, I would bring up two students. One who is very tall, like Sean, and one who is on the smaller side, not as tall as Sean. So almost everybody in the class is shorter than Sean, right? Including me. But it's good to take an exaggerated look. Obviously, if any of us stand next to Sean, his eyes, his normal comfortable view of his eyes are higher off the ground than ours are. They're not as high as his height, but they're higher than ours are. Now, a lot of these problems will not take that person's height into account, but sometimes they do, which is unfair, I know, and I hate to do this to you, but sometimes they do take the height. They'll say like, the string is formed, the kite string, you're holding it 5 feet above the ground. So that is accounting for it. If they don't account for it, honestly, they're really using it as an unimportant value, and they're really going all the way down to her feet. Now, we know that nobody's eyes are at their feet, but they're taking that they're taking it as insignificant, her height as insignificant, okay? I know it's confusing, and I'll try to explain better as best I can. Next, an angle of depression. Okay, the word depression does not have anything to do with sadness, deep sadness, or any mental issue, or even being in your house for too many days because you're quarantined. That's not the kind of depression we're talking about. Okay, the angle of depression is now don't imagine you're Goldilocks. Imagine that you are in the balloon. And your normal line of sight is that red horizontal line. Do you see it? And when you look your eyes down to see Goldilocks, you're using what's called an angle. You're not elevating your eyes, you're lowering them, so it's an angle of depression. For example, you go out for a walk because you're sick of being inside the house so much, and you decide to walk around the block. You walk around the block, and as you're walking, casually you notice something on the ground. You use an angle of depression, and you lower your eyesight down to the ground. You see a $20 bill. Lucky day for you. Okay? No one's around because everybody's quarantined. I think you just made yourself $20 richer by using an angle of depression. If there was $20 on the ground, you're not going to use an angle of elevation, are you? You're not going to look up to see it. You're going to look down to see it. Okay? So the angle of depression is looking down, and the angle of elevation is looking up. Now, let's go back to Goldilocks for a second. Okay? Because here's the important thing. I want to draw in her normal line of sight. Actually, I'm going to ignore her height, and we're just going to go right to her feet. Okay? We're going to say this is the line of the angle of depression. Because this problem has an angle of depression. The angle of depression from the balloon to Kelly is 47 degrees. So here's 47 degrees there. Okay? Now, I want you to... Here's the situation. The hot air balloon is flying at 100 feet. I marked that in for you. The angle of depression from the balloon to Kelly is 47 degrees. What is the horizontal distance from Kelly to the point directly below the balloon? This is what we're... Well, that's a highlighter. Sorry. This is what we're looking for, that value. Okay? Now, we're using... How many people notice that we're going to use this right triangle? Do you see the right triangle? You don't have to answer out loud because I can't hear you. There's the triangle we're using. What's wrong with the 47 degrees? Is it inside the triangle? It's outside the triangle. Okay. You have to have an angle inside the triangle to be able to do sine, cosine, and tangent to it. Right? Because the x is opposite an angle. It's opposite the angle. Let's change colors. It's opposite the angle up here. Okay? Now, there's two ways to get the other two angles. The first way, I'm going to use alternate interior angles. My two horizontal lines are red and green, right? Red and green. Transversal is the pink line I drew. Got it? Now, look at the 47-degree angle. Doesn't it come right down here because they're alternate interior angles? I hope you understand that. If you understand that, you will understand that looking down, from being in the balloon, looking down to see Kelly is the same angle that Kelly would use to look up to the balloon. Does that make sense to you? The angle of depression and the angle of elevation are actually equal. Now, there are some teachers, I'm not really impressed with them. They tell their kids, write the angle of depression down here. Well, that doesn't make sense because you don't understand what a depression angle is then. And that might hurt you later on. All right. The other way you can get the angle, another angle, is you could get this angle because the horizontal and vertical have to be the horizontal and vertical are perpendicular. They make a right angle. So you could do 90 minus 47 and get this angle, which would be, that's 43 degrees. Okay? Now, you don't need both of them. You just need one because you're going to say, okay, I'll do sine of 47 is 100 over x, Or I could do sine of 43 is x over 100. All right? I'm going to leave the work for the trig to you. I'm just going to go through how to do the word problems. Okay, next. So this is just practice. Which angle represents the following situation? And is it an angle of elevation or an angle of depression? Okay, so this is not multiple choice. This is 4 questions. I want you to tell me which angle represents from Jim to the waterfall. So Jim normally looks out here, but he's looking to the top of the waterfall. He's looking up to the top. Because if you've ever been at a waterfall, that's the exciting part, up at the top. So Jim is down here, he's looking up, and he's using an angle of, you tell me, looking up. And which angle would represent that? I marked it. Okay, so pause the video, and I want you to answer from A, B, C, and D. What angle are they talking about? And is it elevation or depression? Pause the video. Yes. Now. Okay, you're back. All right, if you have those answers, here are my answers. Ooh, I just hid them from you for a minute. Okay, so I'm not going to go through all that, but if you have a question on that, let me know. Let's get to a couple more problems. So here's a lifeguard at Rath Park sitting in a chair 6 feet above the pool. I've drew the triangle in for you. You know that question, where is the triangle? I'm drawing it for you. Okay, so he's 6 feet above the pool. He sees a swimmer at an angle of 8 degrees. Now, do not put the 8 in the triangle. Where does this lifeguard usually looking? He's looking at the pool everywhere, but his normal line of sight is there. He has to have a depressive 8 degrees to see the swimmer. That 8 is outside the triangle. Now, you can either you can move that 8 by alternate interior down to here, or you could find this angle up here. I need a new color because you can't see that color. This angle up here, you could find that angle, okay, by using the 90-degree angle there, which is the same as the 90-degree angle there. Parallel lines that are perpendicular to one must be perpendicular to the other. They're interior on the same side of the transversal. So many more reasons why they're both 90. Okay? So get a new angle, and then how far away from the chair is the swimmer? How far away from the chair, from the bottom of the chair? Not from the lifeguard's head. From the bottom of the chair is the swimmer. So there's your unknown. Solve your trig. You know what? This diagram got messed up. We're not gonna worry. Oh, no, I tried to fix it. Okay. At the circus, a person in the audience at ground level watches a high wire routine. You know what? I'm going to end the video here. Forget this problem because it has a couple of inconsistencies in it. I'm going to post a bunch of problems for you to work on this, okay? Word problems and figuring it out. So I'm going to post a homework, and then I'm going to post another worksheet for the next day. Just to let you know, I want to have a classroom meeting with you during 8th period I'm hoping at the end of the week, either Thursday or Friday, when I figure out how this is going to go. So Thursday or Friday, I want to have like a meet with you during our class time, okay? There'll be more on that on my notifications to you, okay? Please email me. I will be glad to get on a live chat with you to help you or fill you in. Try the homework, try to fill in this worksheet and see what you can do. You can ignore that last question about the circus because it got a little complicated and it's unnecessary complication, okay? All right, I hope you're having a great day. I miss seeing your faces, and I'll talk to you soon. Bye.